Hello students, so we are continuing with the third video of the series, and again we are going to take up two very interesting and very expected questions today, and one is of organic and the other one is of inorganic this time. And let's proceed with the first question. I'm putting up the question on the screen. Pause the video, give it a try, read the passage and analyze it properly if you haven't come across this reaction previously, and then see the options, mark your answer, and then we'll proceed with the solution. So in this question we are dealing with the mechanism of Beckmann rearrangement. Now this reaction is not specifically mentioned in the NCERT, and therefore this question, if it comes up ever in JEE Advanced, is expected to come up in the form of paragraph. But to add to the matter, this type of a reaction or a rearrangement is very well within the scope of the JEE Advanced syllabus, and it is this type of rearrangement is somewhat similar to what we see in the Hoffman bromide degradation, and therefore it becomes a crucial topic that should be covered within the discussion. And so proceeding with the question now, we have been given an example case where we are given a case like pH, C, N, lone pair OH, and CH3. So this is the molecule that is given. The first step, it just accepts an H plus, so it protonates, the OH group protonates to give OH2 plus. The second step, it just it is rather a bit of heating maybe, and this OH2 group leaves, and the group that is opposite to the leaving group, in this case water, it migrates to the nitrogen. So the very key element in this case is that the group that is opposite to the leaving group, in this case water, is the one that that actually migrates to the nitrogen atom, and therefore the stereochemistry of this carbon becomes a bit important in this case. So we get the migration, and we get an intermediate, a reactive intermediate of something like this, and this then hydrolyzes to give 2-degree amide, and with the pH and N linkage. Now the first question, or the second question in this case, that asks us is when the CH3 and the pH are just altered, and as a result of which the CH3 becomes opposite to the leaving group, and in that case the CH3 would be migrating, and so the answer of the second question would be PHCO NHCH3. Now when we analyze the question, or rather when we analyze the options, we see that no such option is present. So we assume that this amide undergoes further hydrolysis, so it leaves us with PHCOOH under acidic hydrolysis, and we get methylamine. So this is the final product, which is our option number D. And now coming to the first question, it says that the rate determining step in the Beckmann rearrangement is. So the first step is just the acceptance of a proton by the OH group, and therefore it does not really have a great deal of effect on the rate of the reaction. The third step is also the reaction of a reactive intermediate with water, so it is typically fast. But the second step, that involves the migration of the group opposite to the water leaving group, is indeed the rate determining step in this case. So the answer to the second, or rather the first question, would be B. So this was question number 64, and this was 65. And the third question in this case was we have something like pH and C, N lone pair here, OH, and we have paramethyl. So this is the compound and we are reacting it with PCl5 heat, which is nothing but a dehydrating agent. So the similar type of thing happens and the group opposite to the leaving group migrates, and as a result of which we get something like CONH, and this is the final product. So this matches with option number B. So these are the three answers that we have discussed for questions 64, 65 and 66, and so we'll proceed with the next question now. So this is the second question for today's video, and this is again a question from Alan's All India Open Test, and again this is a question from inorganic chemistry. So the question says that we have a metal cation M2 plus 2, which gives a black precipitate with acidified H2S, and from this information itself we can roundabout guess what type of cations it can be, but let's proceed with the rest of the data first. So it gives that the precipitate dissolves in concentrated HNO3, okay, and the solution of M plus 2 gives a brown precipitate on reaction with potassium ferrocyanide. So this statement confirms that the cation that we are talking about is Cu2 plus. So our cation in this case would be Cu2 plus, and let us write that down first. So we are talking about Cu Cu2 plus as the cation. Now the first option tells that, okay, by the way, this question is a multiple correct question, so uh, let's proceed. So it gives the first question says, the first option says that M2 plus, that is U2 plus aqueous, on reaction with excess of KCN produces a gas. Now this gas is definitely produced because in the first step of the reaction of copper 2 plus with KCN, we get the precipitation of copper cyanide CuCN, which is a white precipitate, and we get the evolution of the cyanogen gas, whose formula is Cn whole twice. So gas is definitely evolved in the process, and therefore option A is correct. Now as it provides excess KCN, so this would not remain as CuCN, but it would form a complex, but that is not the uh, point of discussion here. Now, the second option says that metal M in its extraction process from its most common sulfide ore is obtained from the autoreaction process. Now, the autoreaction process is also known as the self-reduction process, which most of you would have heard who would have studied metallurgy, and it indeed does undergo self-reduction, where Cu2O formed during the roasting is further reduced by the Cu2 is present within the same mixture, and therefore self-reduction or auto-reduction is applicable for metal M, which is copper. The third option says that E naught M plus 2 converting to M is positive, which is true as well. It is given in the NCRT. It is the data given. And the fourth option says that M plus 2 produces a dark blue solution on reaction with excess Cl minus, which is incorrect. It produces somewhat of a white precipitate. So option D is incorrect, and therefore our answer is A, B, and C. And this was a multiple correct question from that involved various chapters such as salt analysis in the identification and option 1. The second option involved metallurgy. The third option involved a bit of D-block data remembering and concepts, and therefore this becomes a very good and expected questions to come up in the future examinations. So this is all for today's video. Make sure to tune in every day to solve more such interesting questions that might just come up exactly
in your paper, and you'll be solving good questions, at least 2 or 3 good questions in chemistry every morning at 8 a.m. So make sure to subscribe and turn on the notifications button so that you never miss these videos and you build a habit of solving good questions every day. Keep learning.